In this video, we'll be talking about the chain rule. The chain rule is a rule that's used to differentiate a function that has another function within it, otherwise known as a composite function. So for example, if we had to differentiate y equals 2 times 3x plus 4 raised to the third power, we would have to use the chain rule. And the reason for that is because we have a function here, 3x plus 4, within another function, and that whole bigger function is 2 times something to the third. So instead of calling something something, I'm going to go ahead and call that something u. So off to the side, I'm going to take note that I'm going to call 3x plus 4, I'm going to call it u. So now we have y is equal to 2u to the third. Now that looks something that we know how to differentiate. So if we differentiate this, we would get, you multiply your exponent by your coefficient, you get 6, and then you take 1 from the exponent, and you get squared. So you get 6u squared. But the problem is we did not differentiate y with respect to x. There was no x. Remember, we changed our x to a u. So we differentiated this expression with respect to u. So we actually found dy over du and not dy over dx. And that's a little bit of a problem, but not so much because now we can actually fix it. So here is the actual chain rule. If you want to figure out what dy over dx is, and you know that y is a composite function, I'll just say composite f, then you can take the smaller function that we did already. We can take the smaller part of the function, the one that's inside, and differentiate it. All right, and here is why. The reason you're doing that is because if you find dy over du, and you find du over dx, well, essentially what you found is dy over dx. So dy over dx is the same as if you differentiate y in respect to u, which we already did over here, and multiply it by if we differentiate u with respect to x, which we're about to do now. All right, so let's finish it, and then I will explain it again in words, and you'll say, oh, that was easier than I thought it was. All right, so we've already found dy over du. So now it's time to find du over dx. So look at that. We have u here. So du, if we differentiate u with respect to x, we get 3. All right, just 3. Which means now that we're ready to find dy over dx, all we have to do is multiply dy over du by du over dx. So what we're doing here is multiplying this by this. So we get 6u squared times 3, which gives us 18u squared. So that's basically the answer, but just remember that there was no u originally in the question. So let's replace that u with what we know u is. So remember that u is actually 3x plus 4. We can know that from the very beginning. So the answer here is 18 times 3x plus 4 raised to the second power. All right, so that seemed like a lot. It seemed like we were doing a lot of steps. It seemed like there was a lot of u's and v's and x's. There weren't any v's, but it seemed like a lot of stuff. I want to do this again, and I want to show you how I think through it with fewer steps, and it will probably help you out as well. Okay, so as promised, I'm going to go through and do this question as I would do it, just voicing the steps that I would use and not throwing the extra variables and all of that good stuff in. All right, so if I had a highlighter, I would highlight this part because it is the function that is within, so that inside function. we're going to treat that function as if it is just its own variable. It's its own thing. It can't be separated. And then we're going to differentiate the whole. So here I have my coefficient, my exponent, and so dy over dx is equal to 12. I'm multiplying my coefficient and my exponent. I'm keeping that variable, that thing highlighted in red here, keeping it the same. So it's 2x squared plus 4. I'm taking 1, I'm subtracting 1 from my exponent, so it is to the first power, so I don't have to write it, but I will anyway. I'll make it look more like a 1 there. And then I have to differentiate that highlighted part here. And whatever I get, I am going to multiply. And let me use black just so we can see that came from that highlighted function there. I'm going to multiply the derivative of that. So we have 4x, and that will give us our answer. So we have here dy over dx is equal to, using my commutative property here, I can multiply that 12 and that 4, and I get 48 times 2x squared plus 4. 48x. There we go. I just took these guys right here, move them over here because they're more comfortable over there, and that's how I think through a question like this. All right, let's do one with sine and cosine. Okay, so this one may look a little scary, but it's actually the same exact rule. We have a function within another function. So if I had a highlighter, again, I would highlight the function that's inside, which is my sine x. And then I would go ahead and differentiate the overall function, treating this highlighted part as if it's just a regular variable, it doesn't change. So when we differentiate cosine, we get negative sine. So when I differentiate the whole, oops, this should be y equals. All right, so when I differentiate the whole, I get negative sine of sine x. But again, remember that you have to take whatever you initially highlighted, that inside function, and you have to multiply by the derivative of that. So the derivative of sine is cosine, so we have to go ahead and multiply by cosine x. All right, and again, it doesn't look that pretty in that order. So I take this guy here, nope, and then move it over here. You cannot break these two up here because it's sine of sine, or negative sine of sine. All right, so then we have here dy over dx is equal to negative cosine x sine of sine x. All right, let's try one more, and then I think you are ready to run with the chain rule. All right, so here we have a function within another function. The function that is inside the other function is our 3x plus 1. So we're going to treat that 3x plus 1 as if it's just a variable. And we're going to differentiate e to the 3x plus 1, but again, we're treating that as that red highlight as if it's just its own variable. So when we differentiate the big function, we get dy over dx is equal to e to the 3x plus 1. Just remember that for an exponential function, when you differentiate e to the x, it's still e to the x, but it's not done. Because now we have to take that highlighted part here, and we have to differentiate it and multiply by what we get. And again, the rule has been the same every single time for every single example. So we're multiplying by, when you differentiate that, you get 3. So we're going to go ahead and multiply by 3. But again, just because it's kind of ugly over there, we're going to take it and we're going to move it over there. And we get that dy over dx is equal to 3 e to the 3x plus 1. So again, if you had to verbalize what you're doing each and every time for these questions, you're taking the derivative of the whole, the big function, and then you're going to multiply it by that derivative of the inside function. And that's really all there is to the chain rule. All right, hope that helped.